Looking at transforming quadratic functions. All right, we know that when a is positive, it opens up. When a is negative, it opens down. And when the absolute value of a is greater than 1, it's narrower than x squared. And when it's wider than 1, we know that the absolute value of a is less than 1. So 3x squared was narrower than 0.5x squared. So when you list these in order from narrowest to widest, we're looking for the largest absolute value first for the narrowest graph. So the largest absolute value would be -2. So that's the narrowest one, is going to be -2x squared. Then we have 1x squared, and then 1/2 x squared. So if you need to, you just change them all to positive, right? Because that's what absolute value is, correct? So if I wanted to order them and I needed to do that, I could just say, okay, this is 1x squared, 1/2 x squared, and even though that says -2, if I'm talking about absolute value, then that would be 2x squared. So if I'm going from narrowest to widest, then it's going to be from the biggest number to the smallest number. So narrowest to widest, -2x squared is first, then x squared, then 1/2 x squared. Okay? All right, so let's look at, let's go back to Desmos then, and we're going to look at changing this a little bit. So leave your x squared there, and go to your y equals ax squared, delete the a, and add c. So it's going to be x squared plus the letter c. Okay? And then we're going to make c a slider. All right? Okay? And so look and see what happens to c as c changes then. What happens as c changes? All right, so when c changes, c is a positive number, it moves it up. C is a negative number, it moves it down. All right, so what we're going to do is we're going to talk about how all the different things come together then when comparing graphs. Okay? So we got three things. We have a when it's positive or negative. Okay, so it opens up or opens down. And a when it means the graph is either going to be wider or narrower. And then we got c, which moves it up or down. So none of them change, or I should say this, is that we're going to be looking at comparing the values of a, b, and c. All right? And mostly we're just going to look at a and c. So how does a affect the graph? How does c affect the graph? All right? So a is only going to affect whether it opens up or down and whether it's narrower or wider, where c is going to change where the vertex is. Because c is going to move the vertex either down if it's negative, move it up if it's positive. All right. So we're going to compare these two graphs, the graph of x squared with the graph of -1/4 x squared plus 3. All right, so let's talk about what's different first. Okay, what's different of -1/4 x squared plus 3 compared to x squared? What's one thing that's different then? All right, Ellie.
A is negative.
Okay, a is negative, which means what? Okay, so it opens down. A is less than 0. Okay, because a is negative. All right. What else? What's another thing? We have two other numbers there. How do those numbers affect how that graph compares with x squared. Right? So what does the 1/4 do? Zach, what's the 1/4 do? Okay, because this is a value of a, right? Because the value of a is negative 1/4, right? So what do we say if this value of a then, because this would be less than 1, right? Okay, so what does that do to the graph? All right, when we were talking about a, we said either it opens up or down, or it's wider or narrower. Okay, so in this case, would it be wider or narrower? Wide. Okay, so since a is equal to negative 1/4, that causes it to open down, and because it's the absolute value of that is less than 1, it means it's going to be wider. All right, and here we got c is 3. All right, so we really want to focus on the a and the c. What do they do to the graph? All right, so what does this 3 do to the graph then, Emma?
Moves it up.
Moves it up. Okay, so it moves up. So that means the vertex is now going to be 0, 3. Because these are all going to be, the x value for these that we're working with is always going to be 0, okay, for the vertex, for these transformations. We're not going to move, we're not moving left or right, we're just moving up or down, okay? Okay, so when you're comparing them, you're going to talk about just A and C and how does that affect them, right? Does it make it wider or narrower? Does it make it open up versus open down? Okay. And what does it do to the vertex? Okay. Let's see what they have here. Pretty much the same, I'm sure. Okay, so the graph is wider. Graph opens down where the original one opened up. They both have the same axis of symmetry. We're not going to worry too much about that. It's always going to, but it changes the vertex from 0, 0 to 0, 3. Okay, so we're going to talk about those specific things. Okay. So for letter B here then, okay, g of x equals 3x squared. All right. So looking at A and C. All right, well, hey, that's great. There is no C, right? So it does not change from, doesn't move it up or down. Okay, it's going to have the same vertex. Okay, the vertex is going to be the same. All right, but what's different? All right, so think about the things that are the same. All right. Since it's positive 3 and C is 0, they're going to have the same vertex at 0, 0, and they both open up. All right. So the difference is that, what does this 3 tell me then? Scott, what's that 3 tell us? Okay, so what does this mean then? When I compare it to x squared, is it narrower or wider? Okay, so narrower. Okay, because a is 3, then g of x is narrower. All right. So we're looking for the things that are the same, things that are different. Here the vertex is the same. They both open up. But it's going to be, g of x is going to be narrower because absolute value of a is greater than 1. Okay. All right. Last one. One more example. Okay, so we're going to do a little application here. All right. The quadratic function h of t equals negative 16t squared plus c can be used to approximate the height in feet above the ground of a falling object, t seconds after it's dropped from a height of c feet. This model is used only to approximate the height of falling objects because it does not account for air resistance, wind, and other real-world factors. Okay? So if I take an object in a sterile room like this is, all right, and I drop it, all right, we're basically talking about that then. All right? So go ahead and put in negative 16 x squared plus c in your Desmos, and then we're also going to pull out our calculator and use our calculator too. But right at the moment, just put it into Desmos. Oops, we got our c there. So all we need is to add negative 16 in front. Oops. Oh, forgot to get rid of that one. Okay, there we go. There's negative 16 x squared plus c. All right, so we know that c gets bigger, all right, it moves it up. Okay, so that means that, so c is actually what number then? When we're talking about an object that is being dropped. What does c refer to then? Any idea? Okay. All right, so we got two identical softballs. Any softball players in here? Two identical softballs are dropped. The first is dropped from a height of 400 feet, and the second is dropped from a height of 324 feet. We're going to write two height functions and compare their graphs. Okay. And then we're going to use the graphs to find out when each softball reaches the ground. All right, and here's where we're going to actually pull out our calculator and use our calculator. So, 400 feet, 324 feet. The height that the object is dropped is just c. Okay, the height the object is dropped is c. So our functions are just going to be negative 16t squared plus 400, negative 16t squared plus 324. So they just differ from the height that they're being dropped. Okay? So they have a different y-intercept. Okay? All right. So we're going to put these two equations into our y equals on our calculator. All right. Negative 16x squared plus 400, negative 16x squared plus 324. And we're going to figure out where or when they reach the ground. Y equals. And we know that the one at 324 is going to reach the ground sooner. Okay. So to be able to see the whole graph, we have to have an appropriate window to see it. Okay. So normally we start out with Zoom 6, Zoom Standard. Okay. And if I go to Zoom Standard, I can see parts of these two graphs, but not the whole thing. Okay. So if I want to see the whole graph, what do I need to change? Okay, because this is the window we have right now. Takes us from negative 10 to 10 on the x, negative 10 to 10 on the y. Okay. What needs to change so I can see the whole graph? The other one. Oh, the y max. Okay, the y max has to change because my y max, I need to get it up so I can see both of them. So I want my y max to be over 400. So we'll make it 425. So whenever you're graphing, all right, if it's a quadratic and it opens up, your minimum, your y min should always be below the vertex, okay? And if it opens down, then your y max should always be above the vertex then. All right, so since my vertex in this case is 0, 400, I need my y max to be bigger than that. Now if I graph it, then I can see these two graphs, okay? So now they want us to figure out when they're going to hit the ground. So it looks like this one is the blue graph, which is our 400, right? Is 1, 2, 3, 4, about 5 seconds. How can I check that to see if it is 5 exactly? Anybody remember? Okay. Trace, type in 5, and hit enter. Okay. Trace 5 and enter. Okay. So the 1 hits the ground because y equals 0, that's my height, after 5 seconds. Right? So the ball that's dropped from 400 feet will take 5 seconds to hit the ground. And then it looks like the other graph is about 4.5. So I type in 4.5 and hit enter. And oops, I'm still in the blue one. How do I change graphs? All right, because it still says I'm on Y1 here. So if you take your arrow keys and go up or down, it'll change it to Y2. All right, if I put in 4.5, and it equals 0. Right? So the one drop from 400 feet is going to take 5 seconds to hit the ground. One drop from 324 feet is going to take 4.5 seconds to hit the ground. And you could find those here also. Oops. All right. The nice thing about Desmos is that it'll give me those points when it crosses the x-axis. Okay. Or if I change it to 324, all right, click on it, 4.5. Okay, so the x value is time, the y value is the height then. All right, so